Lesson 3.1 is on graphing linear equations. In this video, you will learn to identify linear equations, intercepts, and zeros, and graph linear equations. Okay, vocabulary is linear equation, standard form, constant, x-intercept, and y-intercept. In order to understand how to do those objectives that I just mentioned, it's important to understand what the standard form of a line looks like. So, the standard form of a linear equation is ax plus by equals c, where a is greater than or equal to 0. A and b are not both 0. One of them could be 0, but not both of them. And a, b, and c are integers with greatest common factor of 1. So that means if I had like 2, 4, and 8 as A, B, and C, that would not work because the greatest common factor between these is 2. So they have to have the greatest common factor of 1. So they can't all be divisible by the same number. Okay, so some examples are 3x plus 2y equals 5. So in this case, A is 3. So whatever is in front of x is A, in front of y is B, and then the constant by itself is C. And we always want to have x and y on the same side of the equation, and then just a constant on the other side. All right, so let's give these a try. Also, a has to be positive. It can't be 0. I mean, less than 0, negative. So in this case, we want to determine whether this is aligned. So something that's aligned can be written in the form ax plus by equals c. So if I have 5x plus 3y equals z minus plus 2. Standard form gets all the variables on the same side. So I would subtract z from both sides so that I can get a constant over here, just z. So I'd have 5x plus 3y minus z equals 2. But this is not the same thing as this. Okay? I have ax plus by, but then I have this extra thing here. So because of this, the third variable, it means that it is not a line, not a linear equation. Okay? So I can't write it in standard form because it has that extra thing. Now this one, standard form, the conditions that it has, A is greater than or equal to 0, A and B are not both equal to 0, and they are all integers. A, B, and C integers. Okay, so, and we all want to have it in the form ax plus by equals c. So if we have 3 over 4, x equals y plus 8. Standard form has the variables on the same side. So I want to get this y to go to the other side. So to do that, I'm going to do minus y to both sides. So I get 3 over 4x minus y equals 8. Okay, so A is positive, which is good. A and B are not both 0, that's good. But A, B, and C are not all integers. This right here, 3/4 is not an integer. So to make that an integer, I want to get rid of that fraction. So to get rid of a 4 on the bottom, I can multiply by 4 to the top. So, but whatever I do here, I have to do to the entire equation to keep it balanced. So 4 times 3/4 is 3x. 4 times that negative 1 there, it's minus 4y. And 4 times 8 is 32. Are there any numbers in common now between A, B, and C that can be divisible by all of them? Nope. They're all integers. A is positive, and A and B are not both negative, 0. So this is now standard form. Okay. So if we just want to identify what each thing is, A is 3, B is negative 4, and C is 32. Okay, so we want to talk about intercepts. This one says to find the x and y intercepts. So the intercepts are of a segment or where they touch the axis. So a y-intercept is going to be where it touches the y-axis, and the x-intercept is going to be where it touches the x-axis. So looking at this, we're looking at this point right here. to tell us what the y-axis is. And it occurs at 200. So that means our y-intercept is 200. Oops, that's right. And our x-intercept is where it touches the x-axis, which is here at 4. So our x-intercept is 4. So our answer would be B. Okay, we can also find intercepts by looking at a graph. So if I were to graph all of these points, 0, 2,000, 125, 1,500, 250, 1,000, 375, 500, and 500, 0. What do we notice about the points? What is the x value when I'm looking at the y-axis, the y-intercept? So here, this is the point 0, 2,000. Okay, and then this point here, my x-intercept, is the point 500, 0. So I can say that the y-intercept occurs when x is 0, and the x-intercept occurs when y is 0. See that? So my x-intercept is 500, and my y-intercept is 2,000. Okay, so we want to describe what these mean. So looking back at this, what is this saying? So they're saying that when the time is 0 at this point, the weight is 2,000. So we're talking about a box of peanuts being poured into bags. They're saying when before you start to pour, when time is 0, just before you start to pour, the weight of the bag is 2,000 ounces. Okay, so then if we want to know what the x-intercept is telling us, after 500 seconds, the bag is empty, right? At that point, the weight of the bag or the box that you're pouring from is 0. So after 500 seconds, all the peanuts have emptied the bag. Okay, so you can write that down. All right, graph using intercepts. So like I said before, the x-intercept, we said that occurs when y is 0. And the y-intercept occurs when x is 0. Because if I'm going to be on this line for the y-intercept, anywhere on this line, the x value is 0. Anywhere along along the x-intercept, along the x-axis, the y value is 0. So x-intercept is when y is 0, and the y-intercept is when x is 0. So if I want to figure out what my x and y-intercept are of this equation here, I can take 4x minus y equals 4. So to find my x-intercept, I can put in 0 for y. So this is when y is 0. So I have 4x minus 0 equals 4. So this is just 4x equals 4. Divide both sides by 4, and I get x equals 1. So that means my x-intercept is 1. That means when it touches the x-axis, it touches at 1. Okay, and if I want to find my y-intercept, that's when x is 0. So I'm going to put in 0 for x into my equation. 4x minus y equals 4. So I put in 0 here. So 4 times 0 minus y equals 4. That goes away, and I get negative y equals 4. So y equals negative 4. So that intercept is at negative 4. So I have that point, and I have that one. So the line is going to go through those 2 points. You're going to have to excuse my drawing here. It's kind of hard to do on this tablet, but you get the idea. You at home can do it with a ruler and make it look nice. But that's going to be that line graphed. Okay, we can also learn to graph by using a table. So I can say I'm going to put in an x value and see what I get for y. So I'm going to start with negative 2. If I put in negative 2 for x, y is going to be equal to 2 times negative 2 plus 2. So that's negative 4 plus 2, which is negative 2. So that gives me the point, the x comma y. I put in 2, and I got negative 2. Sorry, negative 2, and I got negative 2. Okay, if I put in negative 1, y equals 2 times negative 1 plus 2. That's negative 2 plus 2 is 0. So I get the point -1, 0. If I put in 0, y is equal to 2 times 0 plus 2, and that's equal to 2. So I get 0, 2. If I put in 1, y equals 2 times 1 plus 2, and that's 4. So I get 1 comma 4. And if I put in 2, y equals 2 times 2 plus 2, and that's equal to 6. So I get 0.26. And then if I just go and graph each of these, -2 is right here. And -1, 0 is here. 0, 2, 1, 4, and 2, 6. And we get this, you start seeing this line start to form. And you just connect all of your points. Okay, so those are the 2 ways that you can graph a line. I will scroll through the extra practice problems at the end of this slide, at the end of this PowerPoint, so you can try them if you would like. If not, if you think you've got it, then you may stop here.